Hi, welcome to this breakout session about detailed design and documentation in BricsCAD BIM. My name is Jacob de Sutter, and I will take you through some of the different steps in the detailed design and documentation process inside BricsCAD BIM, highlighting along the way some of the new V23 features that will help boost productivity. We will talk about 4 steps in this process. We'll start off with the detailed design phase, where the model is refined with more detailed geometry and data. We'll also talk about collecting data from different sources and collaborating with different stakeholders by means of open exchange formats and issue management platforms. Next, we'll cover the creation of a 2D documentation set. Plans, sections, elevations, and schedules are all important documents that can be extracted from the model. Finally, you may need to include 2D deliverables to make your set complete. Let's see how BricsCAD BIM V23 will help you in this process. To demonstrate this, we will use this fictitious project consisting of multiple buildings inserted as external references in this overall model. We will focus on this smaller building here, so let's open that drawing. Let's start with the first step in the process, the detailed design phase. In this phase, a designer or engineer will need to turn conceptual spaces into wall layouts and introduce door and window objects in the model. Direct modeling may not always be the easiest way to achieve this. That's why we introduced the concept of top view mode. Top view mode can be accessed through the story bar, which indicates the different stories of the currently active building. If you have multiple buildings in your project, you can still manually switch between these buildings here. Hovering over a story name will indicate that story's floor level in the model. Clicking it activates top view mode. We're actually still in our 3D model. A few things happened when activating this top view mode. First, the camera was set to top view and perspective was turned off if this was active. 2 temporary clipping planes were activated. I can drag these planes up and down to include less or more in the view. Finally, the floor slab and underlying geometry was temporarily set to be transparent and locked. This allows you to see the underlying geometry as a reference, but prevents accidental modification of these entities. If we want, we can change our visual style so it more closely resembles a 2D floor plan. When you are in top view mode, it's easy to use familiar tools like Quick Draw to create an interior wall layout efficiently. Notice that the cursor intelligently snaps to the geometry of the floor below. To refine this experience, we also added a few extras. For example, the Quick Wall tool. This allows us to quickly create interior wall layouts along the X and Y directions of your current UCS. We can hit the Control key to switch directions. We also added dynamic dimensions for walls. Simply select the wall and you will see editable dimension boxes appear. If I want this room to be 3 meters wide, I can simply enter it here. All walls and other entities will maintain their connections. We can now also manipulate walls more easily with operations like trim, extend, and slice. Let's trim this wall so we get an L-shaped connection. Let's also slice this wall here and remove the redundant part. Finally, doors and windows behave differently when inserting them in top view mode. As you are placing the door, a smart interface will let you know when it can be placed in a wall. A green check mark indicates that placement of the door at that location is possible. Like this, it's easy to quickly snap to the different walls and place the door in an intuitive way. Let's flip a few of these doors so they open in the right direction. I'm using the quad for this as this provides easy access to the flip command. Of course, other types of objects can also be inserted from this top view mode, such as plumbing fixtures or furniture. Here, I'm using the library panel that shows the components that come with BricsCAD upon installation. You can also populate this panel with your own components or download manufacturer components from the web, whether they be DWG, Revit families, or SketchUp files. As you can see from this demonstration, top view mode is an intuitive hybrid approach that enables you to work efficiently in a floor plan-like environment, but still gives you all the power and flexibility you are used to in BricsCAD BIM. I can still use direct modeling tools such as push-pull, for example, to extend this wall slightly further. If you need to do other tasks that require you to see the other floors, for example to model a staircase, I can easily turn off top view mode and continue working. In this case, I find it easier to work in a 3D view, so I have a better visual of the staircase context and how it connects to the other parts of the building. Okay, so to recap this first chapter, BricsCAD BIM v23 introduces the story bar, an interface element that highlights the different stories in your building. It gives you access to top view mode, which is a hybrid floor plan-like view of your 3D model. It allows for intuitive modeling with walls by means of the Quick Wall tool, dynamic dimensions and trim extend slice commands, and allows you to insert windows and doors more easily. During this detailed design stage, typically, intense coordination and communication happens between different stakeholders. Designers and engineers need to collaborate to deliver an error-free design to the contractors. In BricsCAD BIM v23, you can import valuable product information from manufacturers and raise new issues to stakeholders. We have improved the interoperability with Revit by enhancing the Revit family import function. Let's import this family of light fixture. A dialog box pops up asking us which family type to import. Let's place this light fixture on this wall. Thanks to the dynamic UCS, I can easily snap to wall surfaces, and I can use dynamic dimensions to position the object at a precise height. I'll use the manipulator to copy it over. After inserting, we can see that the light fixture still has all its important parameters and properties. Things like light intensity, light pattern, color temperature, and energy efficiency are all important parts of the design. These parameters can be imported as custom properties, which can be found in the BIM Properties dialog box. A new namespace is created corresponding with the imported Revit family and containing all the family parameters as custom property definitions. I can see that the BIM type of this object is a building element. This is a generic or overarching type, but we'd like to be a bit more specific. So let's reclassify it by calling the BIM classify command. We have extended the list of possible IFC types in BricsCAD v23 to include many more types. I'll use this search bar here to find the type I'm looking for. Note that we get a little warning saying that it's only compatible with v23 onwards. One of the key concepts of BIM is coordination and communication. In BricsCAD v23, we continue our efforts to improve our BCF panel. It is now possible to create and assign issues in BricsCAD BIM and send them through platforms such as BIM Collab, BIM Track, and BIM Sync. Let's log into one of those services. We can see in the model that the ground floor contains a column. One might wonder why this column does not continue along the first floor, so we will ask the engineer for feedback by creating a BCF issue. We can use the blue plus icon to create a new issue. The issue will contain the current view. Hidden entities will be hidden in the BCF issue, active clipping planes will be maintained, and your current selection set will be maintained when opening the issue in another service. Let's export this model to IFC. We support several versions such as IFC 2x3 and IFC 4. Let's open the exported model in the viewer. I will use one that is compatible with BIM Collab, the BCF service we used. I will now put on a different hat and pretend I'm the structural engineer this BCF issue was meant for. After connecting with the BCF service, we can see the issue appear in the issue list. Opening the snapshot of this issue confirms that indeed only the two walls that were shown in BricsCAD are also shown here. Let's bring back all other entities and we can see that the clipping planes in BricsCAD are also present here. I'll make the slab transparent so I can see the column the issue is referring to. I will now reply to this issue by adding a new comment and snapshot. Going back to BricsCAD and refreshing the BCF panel, we should now see these updates appear. I'll filter on active issues assigned to me to find the relevant issue. So, looking at the major improvements in V23 regarding coordination and communication, we have improved the RFA import functionality to now have the ability to choose a family type, and all parameters are now imported as custom properties. We have extended the list of IFC classification types. We can now create BCF issues within BricsCAD BIM. One of the main benefits of the BIM workflow over traditional CAD methods is the automatic extraction of 2D documentation and schedules out of the 3D model. During the detailed design phase, a lot of documents need to be prepared. Different floor plans, sections, schedules, and material lists. Having these documents available automatically from the 3D model speeds up this otherwise time-consuming task and reduces the chance of human error. These extracted plans can be easily updated with each design change with minimal interaction of the operator. In BricsCAD BIM, the project browser is the central location where you will manage views and sheets. We've made several improvements to this project browser, so let's dive in and talk about these improvements. As you can see, this project already contains a lot of sections and views. These are section planes in the model files. We can select them from the project browser to easily identify them. In this case, they are volume sections, which I put on a dedicated layer so I can easily freeze them or turn them off. In the Sheets tab, we can find all of the sheets in this project. Most of the sections and planes in the project have already been placed on sheets. Let me show you how this was done. Simply select the plans, sections, and elevations you want to place on sheets by holding down the Control button, right-click, and choose Create Sheets. This brings up a dialog with a suggestion based on certain parameters. In this case, I selected 5 views, and based on the default layout size and view scale, we can see that the first 2 views fit on one sheet, and the other 3 views fit on another sheet. Let's change the scale of all 5 views to something smaller and change the layout size to A1. Based on this setup, 2 new sheets will be created, one containing 4 views and another containing 1 view. You can also play around with other settings such as the margins and automatic sheet numbers. Note that the setup dialog also contains a typed plan column. By default, this is empty, meaning that no typed plan will be applied to the view when generating. The line types, colors, annotation styles, and other visual elements of your plans will be based on the project template or on BricsCAD's default templates and settings. I will come back to this later, but now you know that you can already apply a certain type plan to a view in this setup dialog if the type plan is present in the project folder. In this case, I will apply a type plan to this view that will display all load-bearing structures in red and all other objects in black or gray. Once we're happy with our setup, we can create the sheets. They will be based on the project template and will contain empty viewports linked to the associated views. Let's go find our newly created sheets in the Sheets tab. We get an overview of our views per sheet. This overview allows us to move and copy around views from one sheet to another. We could, for example, move this east elevation from the first sheet to the second by dragging and dropping it like this. Or we can copy this floor plan from one sheet to the other by holding down Control while dragging. The project browser also contains a Details tab where you can edit the name, number, and description of the sheet or view. From the project browser, we can update one or more views by right-clicking it and choosing Update Now. This will generate these 2 views in the foreground, which means I need to wait until this operation is finished before I can resume my work. Opening this sheet, we can see that 2 of the 3 views have indeed been generated, but they look completely different. That is because one of them had a type plan applied to it. The load-bearing structure is indicated in red. If we select a viewport, we can see that indeed the structural element strategy is applied to it. This drop-down lists all the available type plans in your project. Setting up type plans has become much more intuitive with the V23 release. If you want to learn more about this, check out the breakout session dedicated to type plans. This viewport also has some other specific properties, such as generate elevation fill and generate background. This elevation fill is especially useful for sections and elevations to display, for example, brick or other materials. We will update this section AA in the background, meaning that we can continue working on other things while this view is being generated. Let's also enable this elevation fill for these 2 elevations, as well as this background image. This is a new experimental feature that will generate a PNG file and attach this image underneath the generated view. It will generate this image based on the current visual style in the model. So if we want our elevation to be, for example, in grayscale, we'll need to choose a visual style that does not display colors or materials. Alright, let's update all these views in the background while we work on our other sheet. We see that in the meantime, this section view has also been generated. Let's annotate this floor plan further. We can add tags automatically based on what's defined in our template. In this case, only door and window labels will be displayed, as well as room tags. We can also add tags manually, such as composition tags, spot elevation tags, or column tags. Dimensioning our elements can be done manually with the classic CAD method, or we can use BIM dimension to help automate this process partially. This command will recognize the 3D model elements you're trying to dimension, allows you to filter on element types or properties, and makes it easy to create dimension chains, for example, on walls and their openings. Another new feature in BricsCAD BIM v23 is a symbolic representation of stairs. This symbol is generated at the moment of section generation. It is done on the fly based on the geometry of the stair in the 3D model, and it does not matter how the stair was created. Whether it was modeled using the stair tool, using direct modeling, or even by importing it from another application, BricsCAD BIM will recognize it as a staircase and will apply this symbolic representation to it. The line types and colors are fully customizable and can be defined in templates. Let's return to our other sheet and check out what these elevations look like. We can see that with this background image enabled, we can create a lot more depth in our elevations. We can make some final changes to our sheet, like cropping our viewports, and we're ready for plotting. Let's check the title block to make sure all the project information is filled in correctly, and we'll plot this sheet to PDF. Alright, let's go back to our model and activate a clipping plane to have a look inside. The model contains a lot of objects like furniture, doors, and windows. What if I want to create a list of these objects displaying their properties and quantities? Such a list, or schedule, was already possible using the data extraction feature. With v23, we have improved this workflow significantly by fully integrating the Bill of Materials Manager in the project browser. This feature, which was originally created for our BricsCAD mechanical users, now fully supports the BIM workflow and allows users to create things like window schedules, concrete quantity takeoffs, and much more. We can include all types of properties like geometric parameters, custom properties, and even generate thumbnail images. The possibilities with this new BOM manager are too much to cover in this session. That's why we dedicated an entire breakout session to this feature. If you're interested, be sure to check it out. So, let's reiterate which improvements were made in the design documentation stage of a project. First of all, the sheet creation user experience has improved greatly. View management is now easier because of the ability to easily move and copy views to other sheets. A new experimental feature is available that generates background images for 2D views, especially useful for elevation views. The creation and management of type plans is now more intuitive and better integrated in the sheet creation process. Stairs now have a symbolic representation on plan views, and last but not least, the Bill of Material Manager now fully supports BIM data, allowing for easy creation of schedules and quantity takeoffs. Often, 2D deliverables are needed in the context of a project. Think about window details, roof cap designs, or construction nodes. Since BricsCAD BIM is basically an extension of the CAD platform, it is really easy and straightforward to integrate 2D drafting into your BIM workflow. We can simply create new sheets in the project and create our 2D content there. I will copy and paste some content from another project in this drawing, but you can of course also create drawings from scratch. Next, I'll add some viewports to this sheet and make sure the scale is correct. This is standard CAD practice, so this should be familiar to people with a CAD background. The BIM project browser now also supports drag and dropping 2D drawing views onto sheets. It's also possible to simply reuse existing sheets from other projects. Since we are making use of the well-known technology of sheet sets, it's easy for CAD users to integrate this in their workflow. To manage this, let's use the Sheet Set Manager. This panel contains a few more functionalities that are not yet available in the project browser, such as importing sheets from existing drawings. Note that this panel also has been redesigned with V23 to have a more modern and user-friendly interface. You can see that thanks to the single BricsCAD platform, integrating 2D deliverables in your BIM workflow is super easy. Okay, so to recap, with BricsCAD BIM being built on top of a general CAD platform, we obtain a seamless integration between 2D deliverables and the BIM workflow. The project browser now supports dragging and dropping 2D drawing views onto sheets, and the Sheet Set Manager was redesigned for a more modern look and feel. Right, so what have we learned today? We've taken a look at the detailed design and documentation phase of a construction project. In this process, I have demonstrated the most important improvements and new features of the detailed design phase, coordination and communication, documentation phase, and the creation of other 2D deliverables. This was a bird's-eye overview of the entire workflow. If you want to go a bit more in depth about certain topics, such as the Bill of Materials Manager or type plans, be sure to watch the other breakout sessions available online. Thank you very much for watching. I hope you found it interesting. If you did, be sure to download the trial and to check out these improvements for yourself. Thanks and have a good day.